So let's go!
But first we have to introduce ourselves. My name is Rehan.
ريهام عيسى. زياد بن عبد الله. مها أمين. اسمها نبيل.
My name is Muhammad Abu Bakr.
My name is Mustafa Ashraf.
My name is Nora Mustafa.
Hello everyone, I'm Mahmoud Musa.
I'm Hussein.
غادة عامر. This is calorimeter. It's a device we use it to make heat measurements necessary for calorimetry. This device consists of metallic vessel are made of materials which are good conductors for heat, such as copper. There is also facility for steering the content of inside the vessels. The vessel is kept in insulating jacket to prevent heat loss to environment. There is also one opening to enable the thermometer to be inserted to make the measurements. The change in the thermal properties of the materials inside the calorimeter. It measures the heat capacity. Its term means to how amount of heat must be necessary to rise the temperature 1 degree Celsius.
This is a conductivity sensor. It consists of many components, including the LED wires, the circuitry housing, and the probes. It is used in measuring the conductivity of the required solution. It's used in many applications such as research, engineering, aquaponics, hydroponics, and freshwater systems because it can also measure the amount of salt, minerals, and the impurities present in water. It uses many methods in working. One of the common methods is the potentiometric method, in which 4 electrodes are placed concentrically in a circle, applying the AC circuit on the 2 outer pair, and then measuring the potential difference from the 2 inner pair. It uses the Ohm's law and the surface area of the electrodes along with the distances to measure the conductivity. And the electrodes in this case is going to be made from platinum. The other method is to make the electrodes filled with an electrolyte of known conductivity.
A DC generator is an electrical machine which is used to convert mechanical energy into direct current electricity. According to Faraday's law of electromagnetic induction, wherever a conductor is placed in a valid magnetic field or the conductor is moved in electromagnetic field, there is an EMF will be produced. We can calculate this EMF using Faraday's law of electromagnetic field. We can use a DC generator as a DC motor and vice versa. Now we are going to explain the components. DC generator, we have here a magnet, copper coil as a conductor. We use this handle to move the coil in the magnetic field to produce electric current. We have here 2 LEDs. Thermal expansion abilities, it's used to measure the linear coefficient of materials that when heated up, it produces a change in its mass. From the equation shown here, the difference in mass equal alpha L the initial mass times delta T, the difference in temperature. To set up this experiment, first we have to measure the initial length of the material we have, like the copper here. Then we fix it inside the foam to prevent the heat loss. Then we fix it inside the images we have. The gauge here, it calculates the difference in length from when the material expands, it push it like that, so it produces a change. Then I fix the heat source from here, and we calculate the initial temperature, final temperature to get the delta T. Then we substitute all the variables we get inside the equation to get the alpha or the linear expansion coefficient.
A micrometer is a highly precise device for measuring tiny objects. It consists of a fixed anvil and a movable spindle, and this is a thimble and this is a sleeve. To measure an object like a razor, you can move the spindle with the thimble until the eraser is exactly pinched between the fixed anvil and the movable spindle. After that, you can take the reading. The reading of the measurement is every mark here above it was 1 millimeter, and every mark down is half millimeter, and every mark here is 0.01 millimeter. So when you measure the aerator, you read this readings. Here is it's 10 millimeter plus half millimeter for this mark, and 0.02 millimeter. And the final step is to make a summation for all these and take the final measurement.
This aluminum needle contains a discharged tube. This discharged tube is held under low pressure, reached to 0.6 mm Hg. This discharged tube has two mirrors at each end. One is transparent and the other is a reflective mirror. When we apply a charge across the discharged tube, this excites the atoms, the helium and neon atoms. These helium and neon atoms reach to high energy levels. They have half-life time. Then they reach to their stable energy level, and their energy in the form of laser light.
Reach, that is a type of varying resistance, and whose resistance can be changed so as to change or adjust the current passing through the circuit. This device, whose name is the rheostat, using two green ports, radios and states, this meaning current controlling device. This device was made by an English scientist called Sir Charles. This is our rheostat. It consists of a slider, a coil, and 3 terminals. Actually, it can be used as a fixed resistance by using these 2 terminals down, or using it as a rheostat by using only 2 terminals. One is fixed here, and other is moving terminal. Actually, the current will pass through this terminal first, and going on there, and passing through the coils and up to the slider, and to the other terminal out of the rheostat. So as when moving the slider here, we will use a very small resistance, but if we move it like that, we will use a very big lens so that the resistance will be increased.
Wave machine. It's an entertaining way of introducing some basic ideas about wave motion, especially transverse wave. It consists of many long steel rods connected by a thin wire. When you move the rod on the end, it transmits energy to the other rod through the wire. Energy here is transmitted in the form of wave.
Students could use the machine to investigate the relationship between wave speed, frequency, and wavelengths. As the law said, speed equals frequency times wavelengths. They could also change various factors and find out how wave speed changes. But first we need to define some definitions, like frequency is the number of oscillations in a specific period of time, and wavelength is the length between 2 successive points, like between a crest and a crest or trough and a trough. Of course, different tones have different wavelengths.
The gold leaf electroscope. It consists of a metal disc, insulation, earth connection, and a glass box. The gold leaf electroscope had a very thin piece of gold foil called the gold leaf, fixed at the top to a piece of copper. This piece of copper has a large round top called the cap. The whole thing is put inside a glass box to stop air blowing the delicate gold leaf around. The piece of copper goes through insulation in the top of the glass box, thus that any change on the gold leaf cannot escape. As shown in this picture, it's an uncharged gold leaf electroscope. Charge can be transferred to the electroscope by whipping the charged object across the cap. The charge flows over the conducting copper and gold, and the gold leaf rises as it becomes repelled by having the same charge as the copper.
Optical fibers are means of transporting data, voice, light and images through the process of total reflection of light passing through the glass fibers of the system that enables it to transmit huge amount of data in very little short time. Scientific fact is that light can only move in straight lines, but in the case of optical fibers, as you can see, these both are not straight, and the light can move to the end of both of them. If we focus in this part, okay, there's a curve on this rod, and the light reaches the end of the rod. Okay, that's all.
The logic gate is an elementary building block of digital circuit. Most logic gates have 2 input and 1 output. At any given moment, every terminal is in one of 2 binary conditions, low or high, represented by different voltage level. The state of a terminal generally changes as the circuit processes data. In most logic gates, the low state is approximately 0 volt, while the high state is approximately positive 5 volt. There are 7 basic logic gates, and gate its symbol is the AND gate. When both inputs are high, the output is high. When one input is high and the other is low, the output is low. OR gate its symbol like a spaceship. When one input is high and the other is low, the output is high. When 2 inputs are low, the output is low. NOT gate is a symbol like triangle and dot. The high and low is reversed. When input is low, the output is high. When the input is high, the output is low. Other logic gates are exclusive OR gate, for short XOR, NOT AND gate, for short N and, NOT OR gate, for short NOR, exclusive NOR gate, for short XNOR.
Ahmed Sayal, we will learn about method induction. The method induction is use AMF in secondary coil from AC current in primary coil.
Here we are our coils. Here is the primary coil connected to the AC power supply to fill the current, alternating current, and here is the secondary coil connected to the load or in voltmeter to measure the induced EMF. Look here. If we begin to turn on the power supply, we will find that there is a current here due to the induced EMF. Look, and if we turn it on, we will observe the voltmeter go as we alternate the current more and more. Hi, I'm Zed Stewa.
I am Ahmed Sayal. I will talk about Yeshu magnet or Horse-Shaw magnet. Horse-Shaw magnet is a magnet that has 2 magnetic fields close together. The purpose of Yeshu magnet or Horse-Shaw magnet is make both close together to make greater magnetic field but same magnetic flux.
To convert the magnetic field from that in the normal pole to that in the closest pole.
Hello everyone, I am Mahmoud Musa.
I am Hussein.
We are talking about pressure gauge, which consists of an instrument that used to measure pressure. That method without liquid, invented in 1844 by French scientist Lucien Vidi.
I can see it consists of small capsule
This capsule we are those needed that shows any change in pressure, we can show it.
Small changes in external air pressure can cause the cell to expand or contract.
Hello everybody, I'm Sam. I'm Mahmoud Musa. We are talking about power supply as we saw that instruments that have many choose current as we can use it for AC current or DC current. Also we can choose any voltage that we need starting from 2 volt ending in 12 volting as increasing 2 volt every time.
For DC we have positive value for here and negative for here. By working for AC DC power supply we will select what we need from voltage such as 6 and the open circuits, connect that with positive, connect that with negative.
Yeah. هو يلا دي
هو يلا